You'll find lines that are perpendicular on the rectangle's perimeter. Or let's break it down even simpler. They make right angles in particular.
Parallel lines never meet. Intersecting lines make V's. Perpendicular lines meet at 90 degrees. Put your hands in the air with me. Parallel, intersecting, perpendicular, irregular.
Hi everyone, welcome to Chapter 3 in Big Ideas Geometry. We're looking at parallel and perpendicular lines in this chapter. There's 5 sections, so we're going to look at our first section today, 3.1, which is talking about pairs of lines and angles. So pairs of lines and angles, we're identifying lines and planes, identifying parallel and perpendicular lines, and also identifying pairs of angles formed by what's called transversals. Alright, so let's go ahead and look at a quick cartoon of the day. So here we go. A little Far Side cartoon. The guy in the car says, "Hey, I'm not crazy. Sure, I let him drive once in a while, but he's never off this leash for even 1 second, or even a second." The dog's driving in the driver's seat. Okay. All right, so as we get into our core concepts, so we're on page 68, where we see the parallel lines, skew lines, and parallel planes. So here's your definitions. You want to highlight through here. So that way you don't have to write them down. If you highlight them, parallel lines here, should know what parallel lines. They do not intersect, and they are coplanar. They would be in the same plane. But they do not intersect, and they are in the same plane. So highlight that part right there. That's what parallel lines are. And skew lines, 2 lines are skew when they do not intersect and they are not coplanar. So they also don't intersect like parallel. They don't intersect there, but they also are not coplanar. So you can see on the diagram we have these ones are parallel here. The one with the little red marks here, that actually those marks are showing and telling us on the diagram that those 2 lines are parallel. It's a way of telling on the diagram that those are parallel lines. Some skew lines here could be this line right here going up and down, which would be line K, and then like line M over here. They're not in the same plane, and they're not also going to touch. They don't intersect. This one that does intersect, so N would not be skew with K because it is intersecting, but M would be skew with K. They're not in the same plane, and they're also not intersecting. And then we have parallel planes of just 2 planes that do not intersect. There are the parallel planes, and so like these 2 planes here are parallel planes, T and U. They're not intersecting. And just a symbol that you want to be familiar with the parallels is the symbol right here means is parallel to, so it's like M is parallel to N. Line M is parallel to line N. Or this right here on the planes, T is parallel to U. So those marks show on when actually we're writing it out, that means they're parallel to each other. So it's just a shorthand way of writing the words is parallel to. You can just write these symbols. So a couple postulates here. That would be on page 68 as well, and then the top of 69. This parallel one is down at the bottom of 68. Just says if there is a line and a point not on a line. So that would be like the black line, then that black point. So the black line L and the black point here P. So P is not on L. That's what it's describing here. Then there is exactly 1 line through the point, through this point, 1 line through that point that's parallel to the given line. So there's only 1 line that would go through this point that would also be parallel to that line. And it also says it this way, there's exactly 1 line through P parallel to L. That's another way you can say it. The perpendicular postulate, kind of similar, so if there again is a line and a point not on the line, so we get line L here in black, point P again, then there is exactly 1 line through point P, through this point, that's perpendicular to the line. So it's very similar, it's the same thing pretty much. And there's exactly 1 line through P that's perpendicular to L. So there's only one line we can draw through P that would be perpendicular to L, and that would be just that red line right there. Any other line that's going through here is going to go not at a right angle, and so there's only one that's actually going to connect and intersect with L at that right angle. Just like up here, there's only one line that's going to be parallel and never intersect with L. Any other line would eventually intersect with L. Okay, so also on page 69 we see this core concept, angles formed by transversals. So transversal is one of the vocabulary words, and you want to highlight, actually no, write that one down there. Actually it's on page 67. So on page 67 where it says transversal, because that's not actually in the core concepts. So this one, you need to copy it down over there on page 67 where the vocabulary is listed for this section. And it says a transversal, it is a line that intersects to form two or more coplanar lines at different points. So basically it's a line that's going through two or more lines there. So it's got to go through at least two lines to be a transversal. It's not just going to go through one line. That would just be an intersecting line. But if it goes through two lines, like we see here, we have two lines, and then you have T going through. T is standing for the transversal. That's going to intersect both lines, so we would call that a transversal. If there was a third line and it would intersect through that, it's still a transversal. So two or more lines, if you have a line that's intersecting, two or more lines, then it's called a transversal. So that's just these lines right here, and they form special angles in here. So angles formed by the transversals, you can see where it intersects here. There's 4 angles where it intersects there and 4 angles here. And so we would got 4 different ways we can identify these angles formed by transversals. You got to get very familiar with these. We use them a lot. So it says the corresponding angles. So again, this is something you want to highlight. These are vocabulary words. What are corresponding angles? The diagram really is the way you want to look at it. You can see there is 2 and 6. They're in corresponding positions. There's more angles that could be in corresponding positions. We could have angles over here and here also in corresponding positions. So let's see, if I did this, an angle here, I could say that's 1 right there, angle 1, and maybe this is 5 over here. Those are also corresponding positions. Another corresponding position could be right here. If I said, okay, this was angle 3 right in this position, and let's say that's angle 7, those are also corresponding positions. And if this is 4 and that's 8, 4 and 8 are also in corresponding positions. So basically, you have it, I think of it kind of as an intersection out on the street, and these are street corners. You got 4 different corners on the intersection, and basically if you have 2 intersections, so here's 2 streets here, and here's a street going down through the middle, intersecting both streets, the corresponding positions would be on the same corner. You're on the same corner, so 2 and 6 are on the same corner, just different intersections. 1 and 5, you're on the same corner, just different intersections. All right, so the next one here talks about alternate interior angles. So alternate interior angles are going to, the word alternate means that they're going to be on the opposite side of the transversal. They're going to alternate over the transversal. So 4 and 5 are in those positions. They are in the alternate interior positions. They're in alternate positions because they're on each side. 4 is on the right side of the transversal, 5 is on the left. And then the word interior means that they're in between the 2 lines. So they're inside the 2 lines. So 4 and 5 are in alternate interior angles. There's only one other pair that could be alternate interior. And let's just say if I put, I don't know, just if I said 1 and 2 right there, that's another pair that's also alternate interior. They're on opposite sides of the transversal and inside those two lines there. The next one is alternate exterior. So the alternate again is the same thing, one on the left, one on the right side of this transversal line, but the exterior means they're going to be on the outside of the parallel, or not the parallel, but the 2 lines here. So 1 and 8, they're on opposite sides and they're on the outside position. So those are the alternate exterior positions. And we could have another one, we could say if I said 2 here, and 7 here, that's another alternate exterior position. That's the only other one that there would be. And then this one here, consecutive interior angles. So the word consecutive would mean on the same side of the transversal. So you can see 3 and 5 are both on the left. They're both on the same side of this transversal line, and interior again means they're in between. So 3 and 5 are in between here. They're on the interior and they're on the same side, so they're consecutive interior. We could also say it this way. I could put 4 here and 6 over here, and there's another pair, 4 and 6, would be also the same thing, consecutive interior angles. So you might want to write those down in this diagram to show, okay, these are all the pairs of these. So there's 4 different pairs of corresponding angles you can get. There's only 2 pairs of alternate interior angles, 2 pairs of alternate exterior angles, and 2 pairs of the consecutive interior angles. As long as you just have 2 lines cut by one transversal, then that's what you'd get. That's what you'd find. All right, let's move on to our extra practice now. All right, so page 70, we see our first 4 problems here in the extra practice. Ask us to think of each segment in the diagram as part of a line. Which line or lines or plane or planes contain point B and appear to fit the description? So right here, they're going to contain point B, which I circle point B over here on our diagram. It's going to contain that point B. So we have to have that point B, and it also has to fit the description here. Like on number 1, it says a line or lines that are skew to FG. So it has to contain B and in a line. So like here we could have a line BC. So we could say that. Because remember it says here, think of the segment here, segment BC as a line. It keeps stretching forever there. We could also have another one, AB, and also another one of BG. So really just there's 3 of them that would contain this point B. So which one of those would be skew? There could be more than one. So if we think about where this FG is, which is over here, okay, well, AB, skew, remember, means that they're not going to intersect, but they're also not in the same plane. AB is on the same plane as FG. They're not going to intersect. It looks like they're probably parallel, but they're on the same plane. BG, right here, would also be on the same plane, and they are definitely going to intersect at point G. So this one right here, BC, doesn't look like they'd intersect. They're definitely not in the same plane. So we're looking at probably BC. Also BD, there's another one, I guess. I wouldn't say that one necessarily. I don't know, they drew a line, I suppose, through here. But I don't know, I wouldn't necessarily include BD. BC is the only one here really on the diagram because of the sides. And BD was not actually a side, so I don't know why they included that one. Lines perpendicular to FG, so what would be perpendicular? It's going to form a right angle, and you can see that's that one right there, BG. So definitely BG is the one that's going to intersect at the right angle. Number 3, we got the parallel to FG. Okay, so which one is parallel to FG? Well, we already talked about that a little bit here, that this one, parallel, is going to be in the same plane and it's not going to intersect. That would be this one right here, AB, if it's going to include that B point. So AB, for that one, that's parallel. And then a plane or planes that are parallel to FG and H. So yeah, look for FG and then H. That's this plane that's right here. So that plane, which one is going to be parallel to that one? And that's plane ABC. That would be the other plane on the other side. So if we thought of this is flat here and that's flat over there, they'll be parallel to each other. They are definitely parallel planes then, one on each side of that diagram. These ones look like they're slanted over here, but these ones on the sides here look like they'd be flat going straight up. Okay, so you just have to watch this one. This is not in the notes. Just watch this. Sometimes you will see like a map here and it'll have lines on them. You just want to recognize certain things about this map, that you can see these parallel marks here, so you can definitely tell those are on the diagram. Those are parallel. The right angle mark tells you something's perpendicular. This line here is going to be perpendicular to this one. So it says name a pair of parallel lines. So that would be with the parallel marks right there. Now notice that these two right here do not show the parallel mark, so we can't really name that one. So the one we're going to name here is the MDFE points. So the MD, and FE. So these ones that have the parallel marks are the ones that we can actually write out that those two are parallel to each other. And the one that says name the pair of perpendicular lines, so that's the one with where the right angle is meeting here. And so that one's going to be MD and BF. And notice this little symbol here. I didn't really mention that before, but this parallel, we have those, that symbol. Perpendicular, you have this symbol. So this little symbol here, like an upside down T, is the perpendicular symbol. That's perpendicular to that one. So this would be the MD, again, this one here, and the BF, that's this one here. And it says, is FE parallel to AC? So is this FE right here parallel to AC right there? And you could definitely see that it's not. It's definitely not parallel. They're going to eventually intersect. And so that's what we see there. All right, let's move it on to the rest of our extra practice. The next part of it here, 5 through 8, just says use this diagram, so kind of similar to that one we were looking at. You can see it's got some parallel lines on here from the parallel marks. It's got the perpendicular right there with the right angle. So I'm going to have you try that one. Go ahead and try to name, do 5 and 6 right there. Name a pair of parallel lines and then name a pair of perpendicular lines. Do that and then go ahead and play the video and see if you name those correctly. Okay, so you should have paused the video and did 5 and 6. So if you didn't pause it, go ahead and pause it and do 5 and 6. So if we name the pair of parallel lines, that's going to be ones with the parallel marks here. So these two are parallel, which would be line WX and line YZ. So those two, also these ones with these two parallel marks. See, this one has one showing these two. These ones have the two showing that those two are parallel. So VU, RQ. So those are our parallel ones. And you could have gone back and forth. You could have called it XW or WX. That didn't really make any difference. Name a pair of perpendicular lines, and that would be the only really one perpendicular mark here. So ST, this line is perpendicular to this one, like VU. You could also call it VN, or you can call it UN, something like that. So one of those kind of ways of calling that. So we have VU, this one here, VU and ST. It also says that QR and ST are also perpendicular. So QR and ST, this one's also perpendicular. Now the reason why that would be perpendicular, okay, that's a good question. It doesn't have the perpendicular mark on this one, but here's why, is because if these two lines are parallel, that means that it's going to be the same situation. If these two lines are parallel, you're going to have this like ST going through. That's kind of like a transversal. And so that makes it, these are all going to be right angles. These will also all be right angles. You can kind of deduce that from this diagram and look at that, kind of using deductive reasoning to be able to figure that out. So this one also would be perpendicular as well because it's parallel to that one. If it wasn't showing parallel, then we couldn't say it, but because it is showing parallel, then whatever goes for this one was going to go the same for that one as well. And number 7, is WX parallel to QR? So is WX, this one here, parallel to QR? And you could see, well, no, that's not. Let's see where to go here. There you are. So no, they are intersecting lines. They are going to intersect. You can see where they intersect on these two right there. Is ST perpendicular to NV? So ST and then NV. So that would be this one here. Are they perpendicular? We already kind of explained that with this one up here. That would be yes. They are. There's exactly one line through V that's perpendicular to ST line. So one line through V that's going to be perpendicular to that. That's according to that postulate we talked about. All right, here's our joke of the day. What did 0 say to 8? So the number 0 talking to the number 8. What did 0 say to 8? Nice belt. Okay, so our last little bit here on the extra practice is going to deal with this here, the different types of those angle relationships and the angle positions. You have the corresponding position, alternate interior, alternate exterior, and consecutive interior positions. Notice every intersection here has the numbers. They're all numbered here. We just want to name and identify all the types of each of these angles. So for the corresponding, remember I told you there's 4 of those. You're going to see 4 types that are corresponding, and there's only 2 types or 2 pairs here for alternate interior, 2 for alternate exterior, and 2 for the consecutive. So for A, our corresponding, you can see there's your 4 types right here, 1 and 5, 2 and 6, 3 and 7, 4 and 8. They're all going to be in the corresponding position. That means they're on the same corner but different intersections. 1 and 5 are on this corner that's on the upper left of the intersection, but different intersections. 2 and 6 are on the upper right. 3 and 7 are on the lower left. 4 and 8 are on the lower right. So those are corresponding positions. Alternate interior. Those are only going to be 2 pairs. You can see there's 2 and 7, 4 and 5. So we're talking about on the inside, that's these numbers on the inside, 2, 4, 5, 7, and they have to be alternate. So 2 and 7 are alternate, 4 and 5 are alternate. Alternate exterior, so there's 2 pairs of those. Again, we're talking about the ones that are on the outside. So we're talking about 1 and 3 and 6 and 8, the ones that are on the outsides of these, but they also have to be alternate. So 1 and 8 are alternate, 3 and 6 are alternate. And then the consecutive interior, so we go back inside these here using the 2, 4, 5, 7, but now we're on the same side of that transversal. So 2 and 5 are consecutive interior, 4 and 7 are consecutive interior. All right, so 9 through 12 gives you a new diagram here. Identify all pairs of angles of the given type, so the same types, corresponding alternate interior, alternate exterior, and consecutive interior. And this one there has 3 different intersections. So there's 3 intersections. They're all numbered. So you got 1 through 4 here, 5 through 8, and then 9 through 12 over here. So you want to go with, all the different pairs. So you can have, let's just kind of give you an idea for corresponding. Now, if I just look at these 2 intersections here, 2 and 10 are in corresponding positions. But also 2 is in a corresponding position here with 6 on those 2 intersections. So this one's going to take quite a bit. There's a lot of corresponding ones here. I'm going to give you some time. Go ahead and just pause the video and try to write down all of these. Look at the corresponding positions. See all the different corresponding positions between these 2 intersections, and then between these 2. And then write them down. So like I already said, you could do 2 and 10, 2 and 6. You could also do 6 and 12. So even on these 2 intersections, you got 6 and 12. So you got basically, 4 pairs between these 2, 4 pairs between those 2, and 4 pairs between those 2. There should be about 12 pairs of corresponding angles. And then do the same thing for alternate interior. And you can just do one at a time. So let's just try doing the corresponding at this point, and then play it after that, just after the corresponding. We can just go over one at a time here, 9 through 12. Okay, so let's go ahead and see if you can check your answer now for number 9. Hopefully you wrote them down. You should have 12 pairs. So here they all are, a whole bunch of them. So you should have a 1 and 5, a 1 and 9, 2 and 6, 2 and 10, 3 and 7, 3 and 11, 4 and 8, 4 and 12, 5 and 10, 6 and 12, 7 and 9, 8 and 11. So that's 12 different pairs of corresponding position angles using this diagram with those 3 intersections. All right, so there's less of these now. This was the most. This one's going to have the most corresponding. Will always have the most. So there's less here. But go ahead and do number 10, alternate interior. So we're looking at the inside ones. So like between these 2 intersections, you're looking at 2, 4, 5, 7. In between these 2 intersections, you're looking at 3, 4, 9, 10. Between these 2 intersections, you're looking at like the 10, 12, and the 8, 7 numbers. So use those and come up with all the different pairs of the alternate interior. So go ahead and pause the video and do that one. All right, so you should have got all of those. Let's see what you should have written down here. So you can go 2, 7, that's these 2. So 2, 7, Those are alternate, or on the different sides of the transversal, but inside you also have 3, 10. So 3 and 10 on these two intersections are also inside and alternate. You have 4, 5. So 4, 5 on these two intersections. You have 4, 9. So 4, 9 on these two intersections. And then these two intersections we still haven't done yet. 7 and 12. There's those two. And then 8 and 10. There's those last two. All right, go on to alternate exterior. So go ahead and do those ones. Write down all of them. There should be the same amount of pairs here. So we had 1, 2, 3, 4, 5, 6 pairs of them. There'll be 6 pairs for the alternate exteriors as well. So go ahead and find all the alternate exteriors. You're talking about the numbers on the outside. It's like 1 and 3, 6 and 8 on those two. So looking at the outside numbers on this one. Let's go ahead and pause the video and do number 11. All right, so let's check your answer for 11 now. All the alternate exterior, there should be 6 of them. So 1 and 12. So 1 on the outside here with 12 on the outside. Remember, they're alternates. They got to be opposite sides of this transversal going through these two intersections. And then 2 and 11. So 2 with 11 on that same intersection there. 1 and 8. So on these intersections, 1 with 8. You're also going to see 3 with 6 there on these same two intersections. And then these last two intersections, you're going to see 5 with 11. And then 6 with 9. Those are also the alternate exterior. These are the outside numbers here that you're working with. So alternate exterior ones. And then do now number 12, consecutive interiors. So we're back inside, like the 2, 4, 5, 7 numbers, those kind of ones. But they're on the same side of the transversal. So go ahead and write all those down. Again, there should be 6 pairs again. So do number 12 and then go ahead and play the video for our last one. All right, so you should have written down the 6 different pairs now of the consecutive interiors. So here they are, 2 and 5. These are on the same side on the inside. 3 and 9 down here between these two intersections are on the same side. We're looking also at 4 and 7 right here. 4 and 10 on the inside right there. You could also do a 7 and 10 on this intersection here. And then you have an 8 and a 12 right there on that intersection. These are still on the inside. Right there on the same side. Inside and the same side as the consecutive interior. All right, so that concludes our lesson on 3.1. So you want to go on to your assignment now on Big Ideas, and I'll see you on the 3.2 lesson.